and also Common Lisp for like 10 years. I also worked with various database systems, and now I'm talking about Datomic and how it fares as a new database that we are using. I'm working for a company that does healthcare backend systems. We do box scale systems, so we don't do great distributed systems other than having to analyze data in read-only modes, but mostly we are running systems that only have 1 million or 2 million users or accounts or stuff like that. So it's not about web scale, and that is also the focus which I use when looking at Datomic. So we are not comparing it to like web scale systems, but rather to things like Postgres or MySQL or whatever have you in a smaller environment. So most of our systems use batch, some form of batch processing. We have file imports, file exports, and most of them are large in the sense of hundreds of megabytes, gigabytes, and we have read-write parity, meaning that we usually inhale some data, then process it and exhale it again. So it's not so much about inserting some little data and then exporting or reading it in many places. But also we are not talking about big volumes, so it's maybe a few gigabytes per month that we process and not terabytes. So what do we want from a database system? Our primary concern is persistence, and when I say persistence, I'm meaning persistence in the sense that we used the word for 30 years before Rich Hickey made it popular in a different sense. So persistence meaning we have some data and store it on disk permanently. We are really interested in writing applications that have persistence as a feature, so we can manipulate persistent data as we would manipulate transient data. And obviously we want our data to outlive our application, so that's why we put it into a database and not into a private format file that we only can use using the original program. So that's why a database makes some sense. So when deciding for a database, there is sometimes there's strict technical requirements, but often it's more the customer wants us to use something, or on Hacker Use I read that this is cool, or this is the best, I have heard it, or MySQL is easy to install, or whatever. And as we are using Clojure a lot, we chose Datomic because it's written by Rich Hickey, and he's a bright guy, so maybe the database is good too. This could be wrong, but anyway. So Rich Hickey has written a database, he's written a cool programming language, and so we tried it, or retry it. We use it in production. So they have some features when they advertise Datomic, and what they advertise is kind of taken back from what they actually talk about. So they have some features like ACID transactions, the joins and sound data model, and query language. And if you look at their talks, it's more like, wow, we have flexible schema and time travel and all these great features that are totally awesome. So it's not so much about, well, it's a database and it can do certain things, but it's also advertised as being particularly great at several things. So we are looking at that too. But if you look at the documentation that they provide, it is, well, to me it was pretty much clear that the API that they are providing is very, very low level. So you get to deal with datums, which is a tuple that you can insert, and you have maps, but that's about it. And it seems that there is some missing middle layer that you want if you want to write an application using Datomic, similar to what you would have in other languages, like in Rails, where you have active record as your middle layer between the application and the database, or in a Java application where you'd have Hibernate. So we are looking for the question marks here. vectors, maps, sets. That's what we use in Clojure. And Datomic advertises itself as, well, having data log and pull expressions and other abstractions that we do not directly manipulate in our programming language. So we looked at a few middle layers, 2 of them actually. We looked at ADI, which is something that makes entities in Datomic more usable and easier to recognize on the source code level. But we found that ADI hides several important aspects of the Datomic API, making the superpowers, the advertised superpowers like time travel, I'll talk about that later, inaccessible to the application. So we ditched that. We also looked at Tuple Datomic, which was presented by its author on the conch, but there is no real story behind that. It's about making Datomic even nicer, but as it's not nice to begin with on the application, on the API, I don't know. I mean, I will probably not start using that. So what we now do is, and I'll show the code, we are using a transparent shim over the API, so that all the calls that the API offers are basically transparently made available to the application. We do some timestamp conversion and DB ident read conversion and transaction retries, which is very limited in what it can do, but it's also something that if you handle transaction retries in your application, it's really sucky. If you have to resolve your DB IDs to enum values, it's also very, very inconvenient. So we have the most basic functionality in our layer, but it still looks like this. And this is not, I mean, it's not terrible, maybe, but it's also not very nice. It's not nice because things are repeated all over, to-do item, to-do list, and then if you are traversing a one-to-many relationship, you have things. Let me try this. This is the label pointer. This is actually not a symbol, but it's interpreted specially, so making this a backward reference. So it's not that easy to understand. And then working with these data structures, like here, it's bearable, but it's also not very nice. So it's not Clojure code that happens to be dealing with persistent data. It's Clojure code dealing with Datomic directly. So we had hoped that a database written in Clojure would be nice for a Clojure application, but the nicety is only on the surface. So the data structures are specified as Clojure data structures. The schema is specified as Clojure schema, but Clojure doesn't really know what a datum is, and Datomic doesn't really know what sets, maps, and lists are, and you get to implement that layer yourself. Also, there's no support for larger objects, anything like that. So it's very, very basic, and well, having dealt with a lot of databases, it more reminds me of like CESAM, or if someone who remembers like that. So very low-level database libraries. Let's talk about Datomic schema. One thing that is, and I'm sorry if this is a rant, it's not really a rant, and I will say the nice things too, but it's, well, you can hear the nice things from Cognitive all the time, so I thought, speaking about the not so nice things. So let's talk about Datomic schema. So in the marketing material, what they say is they have minimal schema, and whatever minimal is, they don't go into that, but they also go into saying that schemaless is powerless. That's a reference. So when I read schema, I read something like Postgres schema, where you can specify constraints on your attributes and have, well, describe your data and the shape of your data in a declarative fashion without having to write code to verify that all the time. So I expect the database to do that automatically. And what we find is that the Datomic schema is not really that. It's not really meant to support the application in specifying the shape of the data. It's more meant to specify the shape of the data so that Datomic itself can operate on it. So every schema feature that you find in the Datomic schema is a feature that helps Datomic, for example, to create a retraction for a fact that you have previously added, or to help them back reference you. So it's really supportive of the internal operation and not so much supportive of the application. Let's look at what I mean. So here's a basic example. I'm boring you to death with the to-do list because you all know that. So there's a to-do list and there's a to-do item, and here's how I would expect this to be specified in some arbitrary schema language. Actually, this is much what we have now, but instead, what they ask us to do in the documentation is this. So they ask us to specify our schema in terms of their internal data structures, the datum, which is very straightforward and very simple, but also totally unreadable. So you cannot read this. And if you remove some of the redundancy, like the DB words and like the cardinality word and all the extra information, then you end up in, oh, sorry, there's this slight missing, like here. So this is what I want to write and read as a programmer, and this is what they suggest I write. So what the schema doesn't provide at all is typed entities. So entities are, well, you can specify attributes, and it's totally up to you to mix these attributes among any entity you have in your database. There's no typing on relationships between entities. Well, all of these things, nothing is there. Everything you can implement yourself, of course, and we are doing that, but it's not something that schema, Datomic's own schema provides, and so minimal really means minimal for the internal operation. So what we do now is we have written our own kind of schema syntax, which is like this. And as you can see here, there's something that is called required, which is a check that this attribute, if we have an entity of that type, that attribute needs to be set. And we parse that representation into Datomic's and Datomic's own schema syntax and into prismatic schema, and then generate a checking function that ensures that when you transact in an entity, you always get the constraints to be matched. This is just, I mean, this is work in progress. But this seems to be working quite well. But on the other hand, what we need to decide now, or what we have decided now, for example, is that entities have types, and that one entity cannot have arbitrarily mixed attributes from other entities, stuff like that, which is part of the flexibility of Datomic, but that flexibility also comes at the price of, well, being not very guiding when you write an application. Another thing that we have to do often, I told you about the volume that we deal with, is bulk data imports. So what we need to do is we get a file every month that is about 2 gigabytes in size, has 2 or 3 million records, and we need to get that into the database. And with another database that supports transactions, we would go ahead like this. We would open a transaction here, then import, and then commit. And only when we commit would a reader read the new data. With Datomic, that is not possible, because the length of your transactions is strictly limited and can only be done, you can only have transactions that are as large as the memory of your peer. Meaning that we need to split up our transactions into small pieces and transact every, 100,000 record to the database, and then all readers read the old data and the new data. And we need to make sure in the reader that the reader filters out anything that it doesn't want to see. So while this is very nice, we have ACID transactions, it is also really not the kind of transaction that I would expect from a database, because I would expect to be able to have multiple operations be executed in one atomic unit, but Datomic doesn't support that. So we do that. We coordinate our readers and filter out data that is not complete yet. But that means that all the readers need to be aware of the entities that are not fully loaded. It also means that if we have to roll back something that is big, we need to explicitly find all the data that we have partially imported and get rid of that. And finally, we have some ideas how the switch flipping from is not completely imported to is imported can be improved through reified transactions, which is nice, but it's not solving the problem that we get to implement what we would like the database to implement. Finally, storing documents. Datomic has a unspoken limit of the attribute size that you can store. So Cognitech says that it's optimized so that each segment can contain a few thousand attributes. So if you put like 10K or 20 or 30K of data, you are overflowing the segment already. So they are not saying, okay, you cannot do this, but they are saying, okay, don't do blobs in your atomic values, in your attribute values. So what we now do is we use Postgres as secondary store for the blobs and commit into Postgres before we commit our data into Datomic. But again, that's on us to ensure that if we abort the import, then we need to roll back the commits that we have done to Postgres. And that makes it other manual. The whole process is manual. The good thing is that we integrated backup and restore. So we have Postgres as backend for Datomic and for the blobs too, so we can use it as a unit and back it up and restore it together, but that's about it. So, conclusions for us. Database is really, Datomic is really a database construction library and not so much a database that would be competitive with other solutions that are databases, like Postgres, but I'm sure that other databases are better too, so like Oracle is, for example. And if you want to use the superpowers that they advertise, like time travel, which is really not time travel, then you need to have substantial experience with the system. So we are still learning it after half a year, and it's not an easy process, and some things just can't be done right now. On the bright side, there are several good things about it too, and this is why we still use it. One thing that I want to mention is the peer storage access and caching. So that means that if you have a reader and read a lot of data from the database and then decide you need to filter it more, usually what you'll get is the data from your own cache and not have to go back to the database server, and that's all fully automatic. You don't need to do anything about that, and that's a result of the architecture giving the readers access to storage and the transactor access to storage separately. Schema as data is cool, and we hope that we will have our own application schema be stored in the database in the same sense that Datomic stores its schema, but it's really constructing something from scratch with the same ideas. Universal history is good, but it's not time travel. So because Datomic is immutable and all data is always stored and all index data is always stored, you can access the data back in history like it was back then. But it's kind of advertised as being time travel, and that's not what it is. So you cannot go back and then change history in any way. You cannot go back and then use the database, make the whole database look like that. So it is really just a part, and time travel is really overselling it a bit, I think. It's testable without mocking, meaning you have a memory transactor and you can just use a real transactor. Is also great for REPL development because the in-memory transactor is co-located in your same process. So when you're writing what you would write as a stored procedure in a different database, you write it in Clojure and you write it in your own process, and you can test it in your own process. That's great. Data log is great, and support is also great. So overall, I think we will keep it. Even though I sound very negative, it's not meant that way. I mean, I'm a programmer, so I can program things, but I'm also a customer, and as a customer, I'm a bit underwhelmed by the database label. Questions?
Loads of the stuff that you've written sounds really useful and also very generic. Is it open source, or could it be?
It could be open source, but it is not right now. So if anyone really wants to use it, I can open source it right now. The problem with it is that it puts certain constraints on what you can do with Datomic, and that's really one of the big problems. Datomic can do everything because it's so low level and so broad. And when you use our library, then you have to do certain things in a certain manner, and we only have a rough understanding what the limitations are. So it's a bit, we don't want to put out something that limits you and then be blamed with limiting you, you know? I mean, but we can do it. It's not a big deal.
How do you find the deployment story with Datomic?
Well, we use Postgres, and for us it's very easy. We build our own RPM and deploy with RPMs, and we don't have the cloud issues, so it's easy for us. But you get a JVM that you need to start where you need to start a jar, and it's fairly straightforward.
Would you do this again on a new project, or was there a massive sort of sunk cost in terms of getting everything to work as opposed to using a conventional database?
I don't know. I frankly, I don't know. I mean, writing database procedures in Clojure is really good, and that's why I would probably use it again if I could.
Okay. So it's been a while since I've used Datomic, but your question about synchronizing, your point about synchronizing readers and not being able to go back in time, I would imagine that the synchronization of readers would just be getting the T and then getting as of T to have a database value that you can read from. Is that not true? What?
That's true. You can. Well, it's history, and it's
yes,
it's more than history, because the whole data set at that point in time in history can be recovered at any time because they don't delete anything, and that's good. But it's not time travel in that you cannot travel there and do things. It's like if you had cameras everywhere and can look everywhere. That's it. Yeah, okay, you can but it's not versioning, and it's not and it's just, I mean, that's why I had this head explodes thing in the beginning. It's easy to interpret what they say as being more what they actually say. Maybe it's me, but that's it. Any more questions? Time on. Thank you.